In the previous video, we learned to resolve a vector into 2 dimension. I mean to say in a rectangular component. Later, we're going to learn in 3 dimension. There, we will have x-axis, y-axis, and z-axis, and we're going to resolve a vector into 3 components. But here now, let's do little more practice of this resolution of a vector into 2 rectangular components, because this is very important, and similar type of the questions. Based on this, you'll get so many types of the questions, and it's really nice to get the concept of this. All right, so resolution of a vector into rectangular component simply means, like, if I have a vector, let's say this is vector 5 Newton. All right, it's a force for a while, and I want to resolve this into 2 components. So trying to resolve into 2 component means trying to find out 2 equivalent vectors, 2 vectors which are perpendicular to each other. All right, just like in rectangular, which are perpendicular to each other, and that is equivalent to the original vector, the 5 Newton. So now I want to find out what is this value and what is this value, which together result to 5 Newton. All right, for that, as we used to do, let's do a little construction here. So let's say this is angle theta. So that time, this will be our perpendicular, this is our base, and this is our hypotenuse. All right, so this is also perpendicular, keep in mind. So if you take cosine of theta, then cosine of theta is base over hypotenuse, and cosine of theta is here, base is our this one, which we need to find out, actually, which we are trying to find out. All right, which is one of our component. So it's going to be hypotenuse cosine of theta, and our hypotenuse is 5 Newton. So it's 5 Newton times cosine of theta. So this is our one component, which is 5 Newton cosine of theta. All right, and now let's find out the vertical component, that is sine theta equals to perpendicular over hypotenuse. All right, this and these are same. All right, keep in mind. So perpendicular over hypotenuse, that is 5 Newton. So again, perpendicular equals to h times sine theta, that is 5 Newton times sine theta. So here we get 5 Newton times sine theta. So always keep in mind the vertical components carry the sine theta, and the horizontal component carry cosine of theta. All right, keep in that mind and see how easily you can resolve now any vector. All right, let's say for a while this is 30 meter, and now I want to resolve this along this, which is 60 degree. Okay, so this will be my, let's say for a while, x component, or you can say horizontal component, and this will be my vertical component. Again, this has 90 degree. All right, here this is 90 degree. All right, so if this is 30 meter, then what will be the horizontal component? So for that, as I told you, h cosine of theta, it means 30 cosine of theta is here 60 degree. All right, so 30 is 30, and cosine of 60, that is 1 over 2, so 2 times 15. So this side we get actually 15 meter. All right, so this side 15 meter. All right, this side 15 meter. This is displacement vector. All right, keep in mind. Now along this side will be now 30 meter. As I told you, vertical component will be with sine, so sine 60 degree. So it's 30, and sine 60 is actually root 3 over 2, 2 times 15, so it's going to be 15 root 3. So this side it will be 15 root 3. Right, so 15 root 3 meter and 15 meters. So this and this together results to 30 meter. All right, so this is how we have to find out the rectangular components. Right, and now I'm giving you a little very interesting question. All right, here we are given a situation. Mass of 30 kg is hanging up in an inclined plane, and we need to resolve that mass hanging up into the two rectangular component, one along the inclined plane and another perpendicular to the inclined plane. All right, so how do we do that? Well, as I told you, as the question is saying, we need to resolve along the inclined plane, and one is perpendicular to this. All right, so we have to take a little brain, we have to use a little brain. This is 30 degree, so this will be definitely 60 degree. All right, so this will be again 30 degree. All right, this is 30 degree. All right, cool. This is 30 kg. If I'm extending a little more, again keep in mind that these are 90 degree. Right, these component and these components are in 90 degrees. So isn't this like, if I'm flipping something like this, I mean to say, if I'm turning like this, then it will be something like this, and 30 degree and this will be 60 degree. So that time this will be, let's say this is 30 kg, which is mg. All right, so this will be mg cosine of 30 degree, and this will be mg sine of 30 degree. All right, this will be mg cos 30 degree, and this will be mg sine 30 degree. So let's find out. All right, so first let's find out mg cosine of 30. So that's going to be, mass is here 30 kg, g let's take 10, acceleration due to gravity, g is here acceleration due to gravity. Keep in mind g equals to 10 meter per second square. This will be given in equation, and then times cos 30, that is cosine of 30 degree, which is 300 times cosine of 30 is root 3 over 2, so 150, and you'll get 150 root 3 Newton, right? So the force acting perpendicular to the inclined plane is 150 Newton. Keep in mind that. All right, and now let's find out towards the inclined plane, that is m, that is 30 kg, g that is 10, and sine 30, that is 1 by 2. So 2 times 5, 5 3s are 15, that is 150 Newton. Okay, 150 Newton along the inclined plane, and 150 root 3, actually I forget here, perpendicular to the inclined plane. This is how we resolved a vector along the inclined plane and perpendicular to the inclined plane.